What if I told you there are planets in the universe where simply standing for a few seconds would kill you? Not because of one reason, but because everything around you is trying to destroy you at the same time. Some planets are so hot, they can melt metal. Some have winds filled with glass, moving faster than a jet. Some are so massive, your own body would collapse under its weight. And then there are places where even time itself doesn't behave normally. But here's the real question. If the universe is filled with such dangerous worlds, then how did Earth become so perfectly balanced for life? And what if that balance is far more rare than we think? Tonight, we're going to explore the most dangerous planets ever discovered. And by the end of this journey, you might start seeing Earth very differently. Before we go deeper into this journey, if you enjoy calm, deep space documentaries like this, consider subscribing to the channel. It helps this content reach more curious minds, just like yours. And now, let's continue drifting through the universe. Imagine you are standing on a distant planet, far beyond our solar system, where every single step you take could be your last. The ground beneath your feet feels unstable, not because it is breaking apart, but because something deeper, something invisible, is pulling you inward. Slowly, steadily, as if the planet itself is trying to claim you. Above you, there is no calm blue sky, no familiar sunlight. Instead, a massive burning star dominates the horizon, hanging unnaturally close, filling the entire sky with an intense, blinding glow. The light is not comforting. It feels aggressive, overwhelming, almost alive. And then, you begin to notice something strange. Your body feels heavier, not in a normal way, not like carrying weight, but as if every part of you is being pressed down, compressed from all directions. Your chest feels tighter. Breathing becomes harder. It feels like the planet is slowly crushing you. This is not imagination. This is not science fiction. This is reality, somewhere out there in the universe. There are planets so extreme, so hostile, that survival is not just difficult, it is almost impossible. Worlds where the laws of nature are pushed far beyond what we experience on Earth. And today, we are going on a journey to one of the most dangerous planets ever discovered. A place where heat, gravity, and pressure combine into something truly terrifying. But the real question is this. If you were somehow taken there, without warning, how long would you survive? Would it be minutes, seconds, or would it end instantly, before you even understood what was happening? To understand this, we need to slowly move away from Earth and into deep space. So far, scientists have discovered more than 5,000 exoplanets. These are planets that exist outside our solar system, orbiting distant stars scattered across the galaxy. Some of these planets are surprisingly similar to Earth. They have atmosphere, temperatures, and conditions that might allow life to exist. But many others are nothing like Earth at all. They are darker, hotter, heavier, more violent. And among these strange worlds, there are a few that stand out. Not because they are beautiful or peaceful, but because they are extreme beyond imagination. One of those planets is known as WASP-12b. The name may not sound dramatic, but what it represents is something far more intense than anything we experience in our solar system. WASP-12b is located about 1,400 light years away from Earth. That distance is almost impossible to truly understand. Even if you could travel at the speed of light, the fastest speed possible in the universe, it would still take 1,400 years to reach it. But distance is not what makes this planet dangerous. What makes it dangerous is where it exists and how it behaves. WASP-12b is what scientists call a hot Jupiter. This means it is a massive gas giant, similar in size to Jupiter, but with one critical difference. It orbits extremely close to its star, so close that it completes a full orbit in just over one Earth day. This proximity changes everything. Because of this, the planet is constantly exposed to intense radiation and heat from its star. The energy it receives is so powerful that the planet itself cannot remain stable. It begins to break apart. Imagine approaching this world in a spacecraft, slowly entering its orbit. At first, you might see it as just another distant planet. But as you move closer, the details begin to appear. The planet glows, not softly, not faintly, but with a deep, burning red color, like molten metal. It does not look solid or calm. It looks unstable, restless, almost like it is boiling from within. And then you notice something even more disturbing. The planet is leaving a trail behind it. A long stream of gas stretches into space, pulled away by the intense gravity of its nearby star. This is not a normal atmosphere. This is the planet itself, slowly being stripped away. WASP-12b is not just orbiting its star. It is being consumed by it. The temperature on this planet reaches more than 2,500 degrees Celsius. To put that into perspective, lava on Earth reaches about 1,200 degrees Celsius. This means WASP-12b is more than twice as hot as molten lava. At these temperatures, metals can melt, molecules break apart, and nothing we know on Earth could survive. If a human were somehow exposed to this environment, even for a moment, survival would not be possible. But temperature alone is not the only danger. The structure of the planet itself creates even more extreme conditions. WASP-12b is tidally locked. This means one side of the planet always faces its star, while the other side remains in permanent darkness. On the side facing the star, the heat is constant and overwhelming. There is no night, no cooling period, only endless exposure to intense radiation. On the opposite side, darkness dominates. But this is not a calm, cold night. Instead, it is filled with violent storms, driven by the massive difference in temperature between the two sides of the planet. These storms move at incredible speeds, creating winds that can reach thousands of kilometers per hour. If you imagine standing on such a world, you would not only be burned by the heat, but also torn apart by the atmosphere itself. The air is not breathable. It is filled with hot gases like hydrogen and helium, moving chaotically, constantly shifting under extreme pressure. And slowly, over time, all of this is escaping into space. The planet is losing its atmosphere, losing its mass, losing itself. WASP-12b is not stable. It is a world in the process of destruction. And if you were there, you would not just witness that destruction, you would become part of it. But as extreme as this planet is, it may not even be the most dangerous place in the universe. There are other worlds, even stranger, even more violent, where entirely different forms of danger exist. Planets where the sky does not rain water, but glass. Worlds where oceans are made of acid. And places where gravity is so strong, it could crush you instantly. So the question remains, is WASP-12b truly the most dangerous planet ever discovered? Or is it just the beginning of something even more extreme? In the next part, we will move deeper into space and explore worlds that push the limits of imagination even further. Imagine a world where it never rains water, where there are no clouds filled with soft droplets, no gentle showers, and no calming sound of rain touching the ground. Instead, the sky releases something far more dangerous. It rains glass, not small particles or dust, but sharp fragments moving at incredible speed, slicing through the atmosphere like invisible blades. And the most terrifying part is that this rain does not fall downward. It moves sideways, driven by winds so powerful that the entire atmosphere becomes a weapon. This is not imagination. This is a real planet known as HD 189733b. Located about 64 light-years away from Earth, this planet might seem relatively close compared to others in the galaxy. But what exists there is completely unfamiliar. At first glance, it might even appear beautiful. From a distance, HD 189733b looks like a deep blue world, glowing softly in space. Its color resembles Earth, reminding us of oceans and calm water stretching endlessly. But this similarity is only an illusion. The blue color of this planet does not come from water. It comes from something far more dangerous. HD 189733b is a gas giant, similar in size to Jupiter, but like many extreme exoplanets, it orbits very close to its star. Because of this, the planet is constantly exposed to intense heat. The average temperature here reaches around 1000 degrees Celsius. This level of heat is enough to melt certain metals and destroy any form of life as we know it. Now imagine approaching this planet in a spacecraft. From space, it still looks calm, almost peaceful. A smooth blue surface covered in what appears to be clouds. But as you move closer, the details begin to change. The atmosphere is not still. It is constantly moving, shifting, and transforming. Massive storms cover the entire planet. These are not temporary weather patterns like on Earth. They are permanent, unstoppable systems that dominate the atmosphere. The winds here reach speeds of more than 7,000 kilometers per hour, several times faster than the speed of sound. At these speeds, the atmosphere itself becomes destructive, but the real danger lies in what these winds carry. Inside the atmosphere of HD 189733b, there are tiny particles of silicate. Silicate is the material from which rocks and glass are formed. Under normal conditions, it exists as solid matter. But on this planet, extreme heat breaks it down into microscopic particles that float within the atmosphere. Now imagine these particles being caught in winds moving at thousands of kilometers per hour. They accelerate, collide, and sharpen. Over time, they turn into tiny, fast-moving fragments. And eventually, they begin to fall. But this is not gentle rain. This is a storm of glass moving sideways across the planet. If you were somehow exposed to this environment, you would not feel raindrops. You would feel impact. Sharp fragments striking your body at extreme speeds, coming from all directions. There would be no time to react, no way to escape. The storm itself would become lethal within moments. Unlike Earth, there is no safe place on this planet. There are no calm regions where the storms stop. The entire world is covered in this violent system, constantly active, constantly shifting. Now imagine standing there on this blue planet. At first, it might still seem beautiful. The color, the glow, the vastness of the atmosphere might feel almost peaceful. But then the wind begins. A distant sound, low and steady, growing louder with each passing second. Soon, it becomes overwhelming. And then the storm reaches you. You would not be able to see individual particles. They move too fast. What you would experience is force, pressure, and impact. The air itself would feel sharp. Every direction would become dangerous. There would be no sense of safety, no direction to escape. Only motion, chaos, and constant force. This is a world where the atmosphere itself is a weapon. A planet where weather is not just dangerous, but actively destructive. And yet, even this is only one example of how extreme planets can become. Because the universe does not stop at glass storms. There are worlds where the danger is not in the sky, but on the surface itself. Planets where oceans exist, but they are not made of water. Instead, they are filled with liquid so corrosive that it can destroy almost anything it touches. Acid worlds where the environment slowly breaks down everything around it. Imagine a place where simply standing still is enough to harm you, where the ground beneath your feet is unstable and the air itself burns slowly over time. These are worlds where survival is not about seconds, but about how quickly destruction begins. So as extreme as HD 189733b may seem, it is still only part of a much larger and more dangerous universe. A universe filled with planets that challenge everything we understand about nature, physics, and survival. And as we continue to explore deeper, we begin to encounter environments that are even more intense. Because there are places where the danger is not heat, not storms, not even the atmosphere. There are worlds where gravity itself becomes the enemy, where simply standing is not possible, where your body does not just feel heavy, but begins to collapse under its own weight, where every movement becomes difficult and every second becomes a struggle against a force you cannot escape. So now the question changes once again. What happens when gravity itself turns against you? In the next part, we will explore worlds where the force that holds everything together becomes the very thing that destroys you. Imagine standing on a planet where simply lifting your arm feels impossible. Not because you are weak, but because the planet itself is too strong. Every movement becomes a struggle. Every step feels heavier than the last. Your body is not just tired, it is being pulled down, forced closer to the surface with an invisible pressure that never stops. On Earth, gravity feels normal. You don't notice it. You walk, run, jump without thinking. But gravity is always there, quietly holding everything in place. Now imagine that same force multiplied, 2 times stronger, 3 times stronger, maybe even 10 times stronger. This is what scientists believe happens on certain super-Earths. Super-Earths are planets that are larger and more massive than Earth, but still rocky, with solid surfaces. At first, they might sound like better versions of our world. Bigger, stronger, possibly even more stable. But that extra mass comes with a cost. Because more mass means stronger gravity. And stronger gravity changes everything. Imagine arriving on one of these planets. Your spacecraft lands successfully, and for a brief moment, everything seems normal. The surface looks familiar. Rocks, mountains, maybe even clouds in the sky. But the moment you try to stand, you feel it. Your body becomes heavier, not slightly, but dramatically. What feels like a simple step on Earth now requires effort. Your legs struggle to support you. Your balance shifts. Even breathing feels different. Because your chest, your lungs, everything inside you is being pulled downward with greater force. Your heart has to work harder to pump blood upward to your brain. Over time, this strain becomes dangerous. Now imagine trying to walk. Each step feels slow. Your muscles burn quickly. Even lifting your arms feels unnatural, as if something is constantly resisting you. If the gravity is strong enough, something even more serious begins to happen. Your body starts to compress. Bones experience more pressure. Joints feel tighter. Your spine carries more weight than it was ever designed to handle. Over time, your structure begins to change under the force. And if the gravity becomes extreme enough, standing might not be possible at all. You would be forced down to the ground, unable to rise, unable to move freely. Now imagine not just standing there, but living there. Everything would be different. Mountains would look flatter because extreme gravity pulls structures downward, preventing tall formations from forming. Trees, if they existed, would grow shorter and thicker. Life itself would evolve differently, adapting to the constant pressure. Creatures on such a planet might be compact, low to the ground, built for strength rather than speed. Their bodies would be designed to resist gravity, not escape it. But for a human, this environment would be overwhelming. Now consider an even more extreme case. There are planets where gravity is not just 2 or 3 times stronger than Earth, but far beyond that. On these worlds, even attempting to stand could result in collapse. Your body would not just feel heavy, it would feel pinned. Every organ inside you would be affected. Blood flow would struggle against the force. Breathing would become shallow. Movement would slow, then stop. Eventually, survival would become impossible. And yet, gravity is not always constant across a planet. On some extreme worlds, gravity can vary depending on location, creating regions where movement is slightly easier and others where it becomes completely overwhelming. Now imagine walking from one region into another. At first, you feel stable. Then, slowly, your steps become harder. Your legs begin to shake. The ground feels heavier beneath you. With each step, the force increases, until eventually, you can no longer move forward. You are held in place, not by anything visible, but by the planet itself. This is the kind of environment that turns gravity into a silent enemy. It does not burn you. It does not strike you. It simply overpowers you. And the most unsettling part is that you cannot escape it, because gravity is everywhere. But even this is not the limit of what the universe can create. There are places where gravity does not just hold you down. It tears things apart. Worlds that exist near extreme objects, where the pull of gravity becomes so intense that it stretches space itself. Near these regions, objects do not simply fall. They are pulled, stretched, and distorted. This is where gravity stops being a force we understand and becomes something far more dangerous. Because there are places in the universe where if you get too close, you would not just feel heavier, you would be stretched into something unrecognizable. So now the question changes once again. What happens when gravity becomes so powerful that it does not just hold you, but pulls you apart? In the next part, we will explore the most extreme gravitational environments in the universe, where survival is not just unlikely, it is impossible beyond comprehension. Imagine drifting through space, far away from any star, any planet, any familiar light, until you begin to notice something unusual ahead of you. At first, it looks like nothing, just a region of darkness, an empty patch of space where stars seem to disappear. But as you move closer, something changes. The stars behind that darkness begin to bend. Their light curves in a strange and unnatural way, as if space itself is being distorted. This is not simply darkness. This is a black hole. A black hole is not a planet and not a normal star. It is a region of space where gravity has become so powerful that nothing can escape it, not even light. That is why it appears completely black. It is not because there is nothing there, but because everything that comes too close is pulled in and never seen again. Now imagine that you are slowly approaching it. Your spacecraft is moving forward quietly, steadily. At first, everything feels normal. Your instruments are working, your body feels unchanged, and the silence of space surrounds you. But then something begins to shift. You notice that the stars around you no longer appear where they should be. Light bends around the black hole, creating strange patterns in the sky. It feels as if the universe itself is warping in front of you. And then, something even more unusual begins to happen. Time starts to change. From your perspective, everything still feels normal. Your heartbeat is steady, your thoughts are clear. But if someone far away was observing you, they would see something very different. They would see your movement slowing down, your actions stretching over time, as if you were moving through something thick and invisible. This happens because black holes do not just affect space. They affect time itself. The stronger the gravity, the slower time moves. And near a black hole, this effect becomes extreme. But time is not the most dangerous part. Gravity is. As your spacecraft moves closer, the gravitational pull increases rapidly. But it does not pull evenly. The part of your body closer to the black hole experiences a stronger force than the part farther away. At first, the difference is small, almost unnoticeable. But as you move closer, it grows stronger and stronger. Your body begins to stretch, not in a normal way, but unevenly. Your feet are pulled harder than your head. Your entire body is being stretched along the direction of the black hole's gravity. This process is known as spaghettification. The name may sound unusual, but the reality is far more intense. It means that an object or a person is stretched into a long, thin shape while being compressed from the sides. Now imagine this happening slowly. At first, you feel tension in your body, a strange pulling sensation that you cannot escape. Then the force increases. Your muscles struggle. Your structure begins to fail. And eventually, your body can no longer hold itself together. This is not something that can be avoided or resisted. It is a direct result of the extreme difference in gravitational force across your body. But even before this happens, there is a point of no return, a boundary known as the event horizon. Once you cross this boundary, nothing can escape the black hole's pull. There is no turning back, no signal that can reach the outside universe, no path that leads away from it. From your perspective, there may be no sudden change at that exact moment. There is no visible line, no barrier. But once you pass it, everything leads inward. Now imagine looking back, trying to see the universe you came from. But you cannot. Light itself cannot escape outward anymore. Everything you see is being pulled forward, deeper into the black hole. At the center lies something we do not fully understand, a singularity, a point where density becomes infinite and the known laws of physics begin to break down. We do not know exactly what happens there, but we do know that nothing survives it. Now imagine a planet existing near such an object, not inside it, but close enough to feel its effects. There are systems in the universe where planets orbit extremely dense objects, including black holes. On such worlds, gravity is never stable. The sky would not look normal. Light from distant stars would appear stretched and curved. The entire universe would seem distorted. Standing on such a planet would feel completely different from standing on Earth. Even light itself would behave in unfamiliar ways. And if the orbit of that planet changes, even slightly, it could begin moving closer to the black hole. Slowly at first, then faster, until eventually it is pulled in. This is a level of danger beyond heat, beyond storms, beyond anything we experience in our solar system. This is where gravity does not just hold things together, it tears them apart completely. And yet, even black holes are not the only extreme objects in the universe. There are stars that are just as dangerous in a different way. Stars so dense, so powerful, that even getting close to them would be impossible. These are neutron stars, and the worlds that exist near them are just as extreme. Imagine a star that no longer burns like a normal star. It does not glow softly like the sun, and it does not spread light gently across space. Instead, it exists as something far more extreme, something compressed to a level that is almost impossible to imagine. This is a neutron star. A neutron star forms when a massive star reaches the end of its life and collapses under its own gravity. The outer layers explode into space, but the core remains. And that core is squeezed tighter and tighter until it becomes one of the densest objects in the entire universe. To understand just how dense it is, imagine this. If you could take a single teaspoon of material from a neutron star, just a tiny amount, it would weigh billions of tons. Not millions, not thousands, but billions. Now imagine standing anywhere near such an object. You would not need to touch it. You would not even need to land on it. Just being close would be enough to feel its influence. The gravity would be overwhelming, far stronger than anything you have ever experienced. On Earth, gravity quietly holds you in place. You can walk, jump, move freely without thinking. But near a neutron star, gravity is not gentle. It is constant, intense, and impossible to ignore. If you somehow tried to stand on the surface of a neutron star, your body would not survive even for a moment. The force would be so strong that your entire structure would collapse instantly. Not slowly, not gradually, but immediately. But the danger does not end with gravity. Neutron stars also rotate, and they rotate incredibly fast. Some neutron stars spin hundreds of times every second. That means a single point on their surface is moving at enormous speed, faster than anything we can imagine in everyday life. Now imagine a planet orbiting such a star, a world trapped in the influence of something so dense and so powerful that every part of its existence is controlled by extreme forces. The first thing you would notice on such a planet is the sky. It would not look normal. The star above would not appear as a large glowing disk like our sun. Instead, it would look small, extremely bright, and intensely focused. A point of light that feels unnatural, almost like a distant but powerful source of energy. And that light would not be harmless. Neutron stars emit enormous amounts of radiation. X-rays, gamma rays, forms of energy so powerful that they can break apart atoms. If you were standing on a nearby planet, that radiation would constantly reach the surface. Without protection, it would damage cells, disrupt molecules, and make long-term survival almost impossible. Even if you were protected from radiation, gravity would still shape everything around you. The pull of the neutron star would create extreme tidal forces. The surface of the planet might not remain stable. The ground could slowly shift, pulled unevenly by the star's gravity. Mountains might crack. The terrain could feel as if it is constantly under pressure. And then there is time. Just like near a black hole, gravity affects time itself. Near a neutron star, time would pass differently compared to regions far away in space. To an observer at a distance, everything near the star would appear slower. But for you, standing there, everything would feel normal. This creates a strange effect, where two observers experience time differently depending on their position. Now imagine trying to live in such an environment. There is no true sense of stability, no calm, predictable cycle like day and night on Earth. Everything is influenced by forces that are constantly active and constantly changing. The atmosphere, if it exists, would be unstable. Radiation would interact with it continuously, breaking molecules apart and altering its composition. Over time, the planet could begin to lose its atmosphere entirely, slowly stripped away by energy and gravity. And yet, despite all of this, some of these planets continue to exist, orbiting neutron stars, surviving in conditions that seem impossible. Now imagine standing there and looking up. You see a star that does not behave like a star. It pulses. It flashes. Some neutron stars emit beams of radiation that sweep across space as they rotate, like a lighthouse beam moving through darkness. If that beam crosses your position, you would experience a sudden burst of intense energy. A flash so powerful that it could affect everything around you. These objects are known as pulsars, neutron stars that emit regular pulses of radiation as they spin. So imagine living on a planet where the sky itself pulses with energy, where light does not remain constant but arrives in bursts, where every few seconds the environment changes. This is not just dangerous, it is unpredictable, and unpredictability makes survival even more difficult, because you cannot adapt to something that never remains the same. Now consider one more possibility. If a planet moves too close to a neutron star, the gravitational forces can begin to tear it apart. Just like near a black hole, tidal forces can stretch and distort objects. Over time, the planet could break apart completely, turning into debris that orbits the star. So even if a planet forms near such an object, its existence may not last forever. This is a level of danger beyond heat, beyond storms, beyond even gravity alone. It is a combination of all these forces working together, creating an environment where survival becomes nearly impossible. And yet, even neutron stars are not the final limit, because there are events in the universe that release more energy in a few seconds than our sun will produce in its entire lifetime. Explosions so powerful that they can affect entire regions of space. Gamma-ray bursts, supernovae, cosmic events that do not just make planets dangerous, but can destroy them instantly. And sometimes, danger does not come from where you stand. Sometimes, it comes from far away, arriving without warning. Imagine standing on a distant planet where everything around you feels calm and stable. The ground beneath your feet is solid, the sky above is quiet, and there are no storms, no extreme winds, no visible danger. For a moment, it feels safe. But in the universe, danger does not always come from where you stand. Sometimes, it comes from somewhere far away, moving silently through space, completely invisible until it arrives. There are events in the universe so powerful that they can affect entire planets, entire star systems, in a matter of seconds. Not slowly, not gradually, but instantly. One of the most extreme of these events is known as a gamma-ray burst. A gamma-ray burst is one of the most energetic explosions in the universe. In just a few seconds, it can release more energy than our sun will produce in its entire lifetime. This level of power is difficult to imagine because it exists far beyond anything we experience on Earth. Now imagine this. Somewhere in the galaxy, far away from your planet, a massive star collapses or two neutron stars collide. In that moment, an intense beam of energy is released into space. This beam is made of gamma radiation, the most powerful form of light. It travels at the speed of light, moving silently, crossing vast distances without slowing down. If your planet is not in its path, nothing happens. You would never even know the event occurred. But if your planet is directly in line with that beam, everything changes instantly. There is no warning, no signal in the sky, no time to react. The energy arrives suddenly, interacting with the planet's atmosphere. Molecules begin to break apart. Protective layers, like ozone, are destroyed rapidly. Without these layers, harmful radiation from the planet's own star begins to reach the surface more easily. At the same time, the atmosphere itself begins to change. Chemical reactions occur as high-energy radiation interacts with gases. The balance that once kept the environment stable begins to shift. On the surface, nothing may seem immediately different. There is no explosion, no visible shockwave. But slowly, the effects begin to appear. Radiation levels increase. Living organisms, if they exist, begin to experience damage at the smallest level. Cells break down. Systems begin to fail. Over time, survival becomes impossible. This is not a gradual change over thousands of years. It is rapid, sudden, and irreversible. Now imagine looking up at the sky during such an event. At first, everything appears normal, but within moments, subtle changes begin to occur. The color of the sky may shift slightly. The air may feel different, heavier, or unnatural. There is a sense that something is wrong, even if you cannot see it. This is the kind of danger that cannot be avoided by movement or escape. It affects the entire planet at once. Every region, every environment, every form of life. And gamma-ray bursts are only one example. There are also supernovae, events where massive stars explode at the end of their life cycle. These explosions release enormous amounts of energy, sending radiation and matter outward in all directions. If a planet is close enough to such an explosion, the effects can be devastating. Radiation floods the system, debris spreads through space, and the balance of the environment is completely disrupted. Unlike gamma-ray bursts, which are focused in a narrow beam, a supernova spreads energy in every direction. This means any nearby planet cannot escape its effects. Now imagine living on a world orbiting a star that is becoming unstable. At first, everything seems normal, but over time, the star begins to change. Its brightness fluctuates. Its energy output becomes unpredictable. The sky might appear slightly different each day, though the change is subtle at first. And then, without warning, the star collapses. In a single moment, it explodes. A wave of energy expands outward, moving through space at incredible speed. The sky becomes brighter than anything you have ever seen, overwhelming and intense. For a brief moment, it might even appear beautiful. But that beauty does not last, because what follows is destruction. Radiation reaches the planet. The atmosphere is affected. Temperatures change rapidly, and depending on how close the planet is, the surface itself may not survive. This is danger on a cosmic scale. It does not depend on the conditions of a single planet, but on the events happening around it. Even a stable world, with the right temperature and environment, can be destroyed if it exists in the wrong place at the wrong time. Because the universe is not still. It is active, dynamic, and constantly changing. Now imagine living in a region of space where such events are more common, where nearby stars are unstable, where neutron stars and massive objects exist close together. In such a region, danger is not rare. It is part of the environment. It does not come from the ground or the atmosphere. It comes from the cosmos itself. This changes how we think about dangerous planets. It is not always about what is happening on the planet, but also about where the planet exists. Location becomes just as important as conditions. A planet may seem calm, stable, and safe, but if it is surrounded by unstable stars or powerful cosmic events, that safety can disappear instantly. This leads to a deeper understanding. The most dangerous environments in the universe are not defined by a single factor. They are defined by combinations. Heat, gravity, radiation, instability, and cosmic events, all working together. And when these forces combine, they create worlds that are not just difficult to survive on, but completely hostile to life. As we move forward, we begin to see the full picture. Not just individual dangerous planets, but the nature of danger itself in the universe. And it becomes clear that survival depends on balance. Because without balance, even the most stable world can become dangerous. Imagine a planet where heat, gravity, storms, and radiation do not exist separately, but all at once. A world where every force in the universe combines, creating an environment so extreme that survival is not just difficult, but impossible in every direction. There are planets in the universe that come very close to this idea. One of them is known as Kepler 70b. At first, it may not sound special, just another distant exoplanet, orbiting a star far away from Earth. But what makes this planet different is how close it is to its star. Kepler 70b orbits so close that it completes one full orbit in just a few hours. Not days, not months, just hours. Now imagine what that means. The planet is constantly exposed to intense radiation, without any break, without any cooling period. There is no night, no recovery, only continuous energy pouring onto its surface. The temperature on this planet reaches around 7,000 degrees Celsius. That is hotter than the surface of many stars. At this level of heat, nothing remains solid. Metals do not just melt, they vaporize. Rock does not stay rock, it turns into gas. The entire surface becomes unstable, constantly changing, constantly breaking apart under extreme conditions. Now imagine standing there. There would be no ground to stand on in the way we understand it. Everything would feel unstable, shifting, almost liquid under extreme heat. The air, if it exists, would not be breathable. It would be filled with vaporized materials, hot gases, and particles moving chaotically. Every breath would be impossible. Every second would be unbearable. But heat is only one part of this environment. Because the planet is so close to its star, gravitational forces are also extreme. The star pulls on the planet constantly, stretching it, distorting it, and affecting its internal structure. This creates a form of instability where the planet is not perfectly round, but slightly stretched, almost like it is being pulled apart. Over time, this stress can cause the planet to lose material, just like we saw with WASP 12b. Slowly, continuously, the planet begins to disappear. Now imagine the sky above you. There is no distance between you and the star. It dominates the entire view, filling the sky with intense, blinding light. There is no darkness, no stars visible beyond it, only overwhelming brightness. The radiation from the star is constant. Ultraviolet, X-rays, energy that interacts with everything it touches. If anything tried to exist on the surface, it would be exposed instantly. There is no protection, no atmosphere strong enough to block that level of energy. And even if there was, it would not last long, because the heat and radiation would slowly strip it away. Now imagine trying to move. Even if you could somehow survive the temperature, the environment itself would not allow stability. The ground shifts, the air burns, the light overwhelms, and gravity pulls constantly. There is no single danger. Everything is dangerous at the same time. This is what makes such planets different from others. On WASP 12b, heat was the main danger. On HD 189733b, storms and glass rain dominated the environment. Near black holes, gravity becomes the primary threat. But on a planet like Kepler 70b, all of these elements begin to overlap. Heat destroys structure. Gravity distorts the planet. Radiation breaks apart molecules. And time itself, under extreme conditions, begins to behave differently. Now imagine observing this planet from space. You would not see a calm world. You would see something glowing intensely, unstable, almost alive with energy. Material might be escaping from its surface, forming a faint trail behind it. The planet would not look permanent. It would look temporary, like something that cannot last. And that is exactly what it is. Planets like this are not stable over long periods of time. They are constantly changing, losing mass, reacting to their environment. Eventually, they may disappear completely, destroyed not by a single event, but by continuous exposure to extreme conditions. Now think about this. If such planets exist, if such environments are possible, then what does that say about the universe itself? It means that the universe is capable of creating worlds far beyond what we consider normal. Worlds where the idea of life, as we understand it, simply does not apply. But it also raises an important question. If there are planets this dangerous, then what makes Earth different? Why is our planet stable, calm, and capable of supporting life, while others become extreme and hostile? The answer lies not in a single factor, but in balance. Earth exists in a region where temperature, gravity, atmosphere, and radiation are all within a narrow range. Not too extreme, not too weak, but just enough to allow stability. And that balance is rare. As we have seen, most planets in the universe do not exist in that balance. They exist in extremes. And in those extremes, survival becomes impossible. This leads us to the final understanding. The most dangerous planet is not just one specific world. It is any world where balance is lost, where one force becomes too strong, or where many forces combine. And when that happens, a planet does not just become different. It becomes hostile to everything we know. The universe is filled with such worlds, and we have only discovered a small fraction of them. There are many more out there, waiting to be found. Worlds even more extreme, even more dangerous, and even more difficult to imagine. And yet, despite all of this, we remain here on a planet that, compared to them, feels almost perfect, calm, stable, balanced, a place where life is possible, in a universe where most places are not. Imagine looking at Earth from far away in space. From a distance, it does not seem special, just another small planet orbiting an ordinary star, surrounded by darkness. And yet, everything about it is different. After exploring burning worlds, violent storms, crushing gravity, and cosmic destruction, one thing becomes clear. Earth is not just a planet. It is a balance. The temperature is not too high and not too low. The gravity is strong enough to hold everything together, but not strong enough to crush it. The atmosphere protects life, while still allowing light and warmth to reach the surface. Radiation from the sun arrives, but most of it is filtered before it becomes harmful. Now imagine if even one of these conditions changed. If Earth moved slightly closer to the sun, temperatures would rise, oceans would begin to evaporate, and the planet could slowly transform into something like Venus. If it moved slightly farther away, temperatures would drop, water would freeze, and the planet could become a frozen world. This narrow region, where conditions are just right, is known as the habitable zone. It is not a guarantee of life, but it creates the possibility for life to exist. Think again about the worlds we have explored. WASP 12b, where heat melts everything. HD 189733b, where glass storms move faster than sound. Worlds near black holes, where gravity stretches and tears apart matter. Planets orbiting neutron stars, where radiation dominates the environment. And cosmic events, where entire planets can change in seconds. Compared to all of this, Earth feels calm, stable, and predictable. But this balance is not common. It is extremely rare. Most planets in the universe do not exist in this narrow range. They are too close to their stars or too far away, too massive or too small, too unstable or constantly exposed to extreme forces. Now imagine standing on Earth again. You can walk freely. You can breathe without effort. You can feel the ground beneath your feet without being crushed, or burned. These simple experiences are not simple at all. They are the result of multiple forces working together in perfect balance. The atmosphere protects the surface and helps regulate temperature. The magnetic field shields the planet from harmful solar radiation. The moon stabilizes Earth's rotation, preventing extreme shifts in climate. And the distance from the sun keeps water in liquid form, which is essential for life as we know it. Now imagine removing any one of these factors. Without the atmosphere, radiation would reach the surface directly. Without the magnetic field, solar winds would slowly strip away the air. Without the moon, Earth's tilt could change unpredictably, leading to extreme environmental changes. Each element plays a role, and together they create stability. But even with all of this, Earth is not completely safe. Because danger in the universe does not always come from the planet itself. Sometimes it comes from outside. A nearby supernova, a passing object, or a rare cosmic event like a gamma-ray burst. These events are unlikely, but they are not impossible. And this is what makes the universe so fascinating. It is not designed to be safe. It is not designed to support life everywhere. Instead, it creates conditions, and only in rare situations do those conditions align in a way that allows life to exist. Earth is one of those rare situations, a place where balance exists, a place where life can grow, adapt, and survive. Now imagine how different things could have been. If Earth had formed slightly closer to the sun, or if its mass were slightly different, or if its atmosphere had developed in another way, even small changes could have transformed it into a completely different world. A world like the ones we have explored. Hostile, extreme, uninhabitable. This realization changes how we see our planet. It is no longer just home. It is something rare. And when we look out into space, searching for other worlds, we are not just searching for planets. We are searching for balance. Because without balance, even the most beautiful world can become dangerous. And with balance, even a small planet can become a place where life exists. In a universe filled with extremes, Earth remains something different. Not perfect, but balanced enough to allow something extraordinary. Life. Imagine looking out into the universe again after everything you have seen. Burning planets, glass storms, crushing gravity, collapsing stars, and sudden cosmic explosions. Slowly, your understanding begins to change. The universe no longer feels empty or silent. It feels extreme, active, and constantly shifting. Everywhere you look, there are worlds that challenge the idea of survival. Planets where heat melts everything, where winds destroy anything in their path, where gravity becomes overwhelming, and where radiation reshapes entire environments. These are not rare exceptions. They are common. The universe does not easily create safe places. It creates extremes. And within those extremes, only a few worlds manage to exist in balance. Think about the planets we explored. WASP 12b, slowly melting under intense heat. HD 189733b, where glass storms move faster than sound. Worlds near black holes, where gravity stretches and distorts everything. Planets orbiting neutron stars, where radiation pulses constantly through space. And cosmic events, where entire environments can change in an instant. Each of these represents a different kind of danger. Not just one condition, but a combination of forces working together. This leads to an important realization. The most dangerous planet is not defined by a single factor. It is defined by imbalance. When temperature becomes too high, structure breaks down. When gravity becomes too strong, movement becomes impossible. When radiation increases, life cannot survive. And when stability is lost, everything begins to change. Now imagine combining all of these conditions into one world. A planet that is too close to its star, exposed to extreme heat. A planet with strong gravity, pulling everything downward. A planet with an unstable atmosphere, constantly shifting and escaping into space. And a planet located in a region filled with cosmic events. Such a world would not just be dangerous. It would be completely uninhabitable. And yet, the universe is capable of creating such places. Worlds where multiple extremes exist at the same time, interacting and amplifying each other, creating environments far beyond anything we experience on Earth. Now imagine discovering such a planet. From a distance, it might appear ordinary, just another point of light in the vastness of space. But as you study it, as you begin to understand its conditions, it becomes clear that it is not just different. It is hostile in every possible way. This is what makes the search for life so difficult. Finding a planet is not enough. The conditions must also be right. And right does not mean perfect. It means balanced. A planet must have the right temperature, the right atmosphere, the right level of radiation, and the right gravity. Not too extreme, not too weak, but somewhere in between. This balance is rare. Out of thousands of discovered exoplanets, only a small number exist in conditions that might allow life. And even among those, many uncertainties remain. This means that most planets in the universe are not like Earth. They are not calm, not stable, not suitable for life as we know it. They are extreme. And yet, this is what makes the universe fascinating. Even in a place filled with danger and instability, there are still rare moments of balance. Rare worlds where conditions align just enough to allow something different to happen. Life. Now imagine standing on Earth again after exploring all these worlds. The ground feels stable. The air feels calm. The sky feels familiar. These simple experiences are not simple at all. They are the result of a delicate balance that exists in only a small number of places in the universe. And this leads to one final understanding. The most dangerous planet is not just one specific world. It is any world where balance is lost, where one force becomes too strong, where conditions move too far from stability, where survival becomes impossible. The universe is filled with such worlds. We have only discovered a small number of them. There are many more, waiting to be found, more extreme, more dangerous, and more difficult to imagine. And yet, despite all of this, we exist here, on a planet that, compared to the rest of the universe, feels almost perfectly balanced. A place where life is possible, in a universe where most places are not. Imagine stepping back one last time and looking at the universe as a whole. Not just one planet, not just one system, but everything together. Billions of stars, countless planets, endless regions of space, each with its own conditions, its own rules, its own level of danger. And slowly, a pattern begins to appear. The universe is not calm. It is not gentle. It is not designed for comfort. It is extreme. Everywhere you look, there are worlds that push limits. Planets that burn under intense heat. Worlds where storms never stop. Places where gravity becomes overwhelming. And regions where radiation reshapes everything. These are not rare exceptions. They are the natural outcome of how the universe works. The universe creates extremes first, and only sometimes it creates balance. We explored planets that melt under their own temperature, worlds where glass moves through the air like rain, environments where gravity compresses everything, and regions near black holes where even time itself begins to change. We saw planets near neutron stars where radiation pulses constantly, and cosmic events where entire environments can change in seconds. Each of these showed us something important. Danger in the universe does not come from just one thing. It comes from forces becoming too strong, from balance being lost. And this leads to the final understanding. The most dangerous planet is not just one specific world. It is any world where conditions move beyond balance, where heat becomes overwhelming, where gravity becomes crushing, where radiation becomes destructive, and where stability disappears. Now imagine all of this together. A planet too close to its star, constantly burning. A planet with strong gravity, making movement difficult. A planet with an unstable atmosphere, slowly escaping into space. A planet exposed to cosmic events, unpredictable and powerful. Such a world would not just be dangerous. It would be completely uninhabitable. And yet, these kinds of worlds are not rare in the universe. They are everywhere. Now think about Earth again. A small planet orbiting a single star in a quiet region of space. At first, it may seem ordinary, but after everything we have explored, it becomes clear that it is not ordinary at all. It exists in balance. Not too hot, not too cold, not too heavy, not too light, protected but not isolated, active but not unstable. This balance allows something that most places in the universe cannot support: life. Now imagine how easily this balance could have been different. A slight change in distance, a small difference in mass, a change in atmosphere. Even minor variations could have created a completely different world, a world like the ones we explored, hostile, extreme, and impossible to survive. This realization changes the way we see everything. The universe is not built for life. Life exists only in rare conditions, in small windows where everything aligns just enough to make it possible. And that is what makes Earth special, not because it is perfect, but because it is balanced. As we continue to explore space, discovering new planets and new systems, we are not just searching for places that look like Earth. We are searching for places that share this balance, because without it, even the most beautiful world can become dangerous. Somewhere out there, there may be other planets like ours, worlds where conditions are just right, worlds where life might exist. But they are rare, hidden among countless worlds that are far more extreme. And until we find them, we remain here on a small, balanced planet, in a vast and powerful universe, a place where, against all odds, life exists. If this journey made you look at the universe differently, then you're going to enjoy what comes next. Subscribe for more slow, deep explorations of space, where we uncover the quiet mysteries of the cosmos. And if you made it this far, comment "Earth is rare." I want to see how many of you stayed till the end.